Problem 35, evaluate the integral of 5x over x squared plus 3 cubed dx. Alrighty, since I see some parentheses and things in the denominator, I'm going to let u be what is inside the parentheses. So u will equal x squared plus 3, which means du is 2x dx. I notice I have a 5x dx. I want 2x dx, so I'm going to multiply by 2/5 on the inside, which means I need to multiply by 5/2 to undo it on the outside. So now I'm going to look at what I have. I have 5/2 on the outside, and then on the inside, all this stuff up top turned into du, and then x squared plus 3 was u, so I have it over u cubed. And I'm still not quite ready to take the integral. This is not an ln problem because I have a to a third power. So when I rewrite this, it's going to be 5/2. This is actually going to be u to the -3 du, and then from here I can use my power rule. I can add 1 to the power, so I'm going to get u to the -2, and then I always put the reciprocal out front, so it's going to be -1/2, and then I still have my 5/2 on the outside. So now just cleaning this up a little bit, multiplying the 5 times the -1 will give me -5, and then 2 times 2 will give me 4, and then I'm going to move the u to the -2 back down to the denominator, and then just rewriting it, I'm just going to replace my u back in the problem. So I'll have x squared plus 3 to the second power, and then plus c. Okay, problem 6, evaluate 7 to the 4x dx. I notice that that is taking the format of a to the u du, and when I do that, I know I'm going to end up getting a to the u over ln a. So that's what I'm going for. So if I have a constant base, I'm always going to let u be my exponent, so we'll let u equal 4x, and then the derivative of 4x is 4 dx. I notice that I'm missing the 4, so I'm going to put a 4 on the inside, which means I have to put a 1/4 on the outside. So now if I go to rewrite this, I'm going to have 1/4 7 to the u du, and then I'm going to just bring my 1/4 down. The derivative of 7 to the u is 7 to the u over the natural log of 7, and then I'll just replace my u back in. I'll get 7 to the 4x divided by 4 ln 7 plus c. All right, problem 37, find the second derivative to the function f of x equals ln x plus 5x squared at x equals 7. So I'm going to take the second derivative. I want to get to f double prime, and then when I'm done, I'll plug 7 in as an answer. Okay, so the first derivative, since there's a plus sign, we can just take the derivative of each part separately, and since I have an ln, I know that the derivative of ln is du over u. U in this case is x, so my answer is going to be 1 over x, and then plus the derivative of 5x squared will be 10x. And then before I take the derivative, I'm going to rewrite my 1 over x. Rewritten, that would be x to the -1 plus 10x, and now I'm ready to take the second derivative. And again, since there's a plus sign, we can take the derivative of each part separately. So I'll bump my -1 out front, so I'll have -1x, and then I'll decrease my power by 1, so -1 minus 1 would be -2. And then plus the derivative of 10x is just 10. And then I'm going to rewrite that so I don't have a negative power, so this will be -1 over x squared plus 10. And then they ask me to find the second derivative at 7. So if I plug 7 in, I'll have -1 over 7 squared plus 10, which gives me -1 over 49 plus 10. And I could go a little bit farther. I'm going to go ahead and get a common denominator. So -1 over 49, and this will be also over 49. 10 times 49 will be 490. So if I go ahead and add like terms now, I will end up getting 489 over 49. That will be my second derivative. Okay, last one here. The graph of f is shown on the interval -2 to 6, and g of x is the integral from 0 to x of the function. Okay, before I even start this problem, I know that g is going to be the area under the curve. I know that g prime is going to be the curve, and I know that g double prime is going to be the slopes of the curve. All right, so in this first one, it's asking me to find g of -2. So I'm going to go back up to this original problem, and instead of this x right here, I'm going to put a -2. Okay, so this is basically telling me to find the area under the curve from 0 to -2. Well, I'm not allowed to go from 0 to -2, so I'm going to make it the opposite of the area under the curve from -2 to 0. Okay, so going from -2 to 0 is going to be this portion right here, and I notice that that is a quarter circle. So I'm going to get a negative, and it's going to be 1/4 pi r squared. And in this case, the radius of that circle would be 2, so it's going to be negative 1/4 pi times 2 squared. And 2 squared and the 4 will cancel each other out, so I just end up getting negative pi as my answer on that one. Okay, the next part of that asks me to find g prime of 4. And g prime of 4, I know it's just looking at the curve at 4. So when x equals 4, my y value will be 3. And then g prime of 0, again, I'm just looking at the curve. So at 0, my y value would be 2. And then my next one, it says to find g double prime of 0. So I need to find the slope of the curve at 0. So when x equals 0, I notice that the slope or the derivative there is actually just 0 because there's a horizontal tangent line there, so that would just be 0. And then the last one, g double prime of 4. If I go to 4, I notice that there's a sharp turn and we can't find the slope or the derivative there, so that would be does not exist. All right, for part B, where on the interval is g increasing and decreasing? Okay, in order to find increasing and decreasing, I need to make a g prime chart. And if I'm looking at g prime, I'm just looking at the curve. So I notice that the curve equals 0 at 2. And then again at 5. Okay, before I get to 2, and I'm not including this one because that's just the endpoint of my interval, so it's not necessary. All right, so before I get to actually, that's just 2, not negative 2. 2, whoops, excuse me. Okay, 2. Before I get to 2, my graph is above the x-axis, so g prime will be positive. Between negative 2 and 5, my graph is still above the x-axis, so it is still positive. And then after 5, my graph is below the x-axis, so g prime will be negative. So if I'm discussing where g is increasing and decreasing, I would say g is increasing on the intervals. I'm going to start at the endpoint of my interval, which happens to be negative 2, and it's going to increase until I get to 2, and then it's also going to increase from 2 to 5. Notice I split them into two separate areas because at 2, the derivative is actually undefined. So it's increasing on those intervals, and that would be because g prime is positive. And then we could say that g is decreasing on the interval. We would say 5 to the endpoint of the interval, which is 6. And that would be because g prime is negative. All right. Let's take a look at this next one. It said to find the x part. See, it said to find the x coordinates of all relative extrema. I'm still talking about g prime, so I'm going to use the g prime chart that we had just drawn on the other page. I'm just going to redraw it. Okay, and if I'm looking for relative extrema, I'm looking for where g prime either changes from positive to negative or negative to positive. We would not include 2 because it's not changing, g prime is not changing sign there. But I would say that g has a relative maximum at x equals 5, and that would be because g prime changes from positive to negative. Okay, and then the next one, it's asking where on the interval is g concave down. G being concave down has to do with g double prime. G double prime has to do with the slopes of the curve. So I notice that the slopes are positive till I get to 0. And then they are negative till I get to 2. And then they are positive till I get to x equals 4. And then the slopes are negative the whole rest of the time after that. So when it's asking me for where is g concave down, I'm just going to circle the 2 places. So I would say g is concave down on the intervals. We're going to go from 0 to 2, and then we're going to go from 4 to the interval ends, which is at 6, and that would be because g double prime is negative. Okay, and then my last one, I would like to find points of inflection. Points of inflection would occur wherever g double prime changes sign. So it changes sign at, so I'm just going to say points of inflection occur at x equals 0, 2, and 4, and that would be because G double prime changes sign.